This isn't really as crazy as it sounds to be. Yeah, basically, there's a standard approach in matrix algebra where you can raise a matrix to power of e, you can raise a matrix to the power of 1000, you can take log of matrix, you can also take Lambert W of matrix. You can do any of such stuffs basically with a standard approach which I'm going to share in this video. So basically, if you have matrix A, first of all you have to express this matrix as P D P inverse, where D is a diagonal matrix whose diagonal elements are lambda 1 and lambda 2, where lambda 1 and lambda 2 are the eigenvalues of matrix A. Yeah, and P is formed by the eigenvectors of A1, A2 as the first eigenvectors and B1, B2 as second set of eigenvectors. Yeah. So P is formed by two pairs of eigenvectors of A. D is formed by two eigenvalues in the diagonal element in the main diagonal. And after you have P and D with you, then what you can do is now there's another formulas which I have already proved in my playlist of matrix algebra over here. The formulas are something like this. Basically, if you want to take a to the power n, this will just be p times d to the power n p inverse, and this implies all the other formulas like taking e to the power a, that will just be p times e to the power d p inverse. If you want to take log of a, that will just be p log of d p inverse. If you want to take Lambert W of a, that will also just be p times Lambert W of dp inverse. And now how to find d to the power n e to the power d ln of d Lambert W of d? For that, d to the power n will just be lambda 1 to the power n, lambda 2 to the power n 0 0. I have already proved this in my playlist, okay? And now e to the power d will also just be e to the power lambda 1, e to the power lambda 2, 0 0. Yeah. Similarly, ln of d will just be ln of lambda 1, 0 0, ln of lambda 2. Yeah. And similarly, Lambert W of d will just be Lambert W of lambda 1, 0 0, Lambert W of lambda 2. So basically the main thing is to find the d and p, because after you have found d, then it's really easy to do any of such operations, either raising to the power of e or log or lambda w, anything as such. So for that, let's begin to find eigenvalues and eigenvectors of this matrix. A equals to 0 pi minus pi 0. For finding eigenvalues, we need to solve this determinant. A minus lambda I is equals to 0, and for finding eigenvectors we need this equation, that is a minus lambda I times eigenvector xy is equals to 0. Okay, now to solve this determinant, minus lambda and then pi minus pi, okay, is equals to 0. Now this is just lambda square plus pi square is equals to 0, so lambda equals to plus minus I pi. Yeah. So now let's try to find eigenvectors for each of the case when lambda equals to I pi and when lambda equals to minus I pi. When lambda equals to I pi, our a minus lambda I will be, what will it be? A is that matrix, yeah, a minus lambda I, so minus I pi minus I pi pi minus pi. This times xy should be 0, yeah. Now if you multiply minus I pi x plus pi y is equals to 0, Other equation will also give the same answer, so we can just deal with one equation. Now one of the solutions for xy is basically, if we take x as I, this will just be pi only and minus 1. Okay, so you can take any other vectors as well, any eigenvector, but anything will work. Now when it's minus I pi, we will have I pi, pi minus pi. Okay, and then xy, this will be 0, and then we have I pi x plus pi y is equals to 0. Now for this case, xy need to be if x is I, we have minus pi, so y can be 1. Okay, so now we finally have p, because p is just a combination of both the eigenvectors I minus 1, I 1, yeah, and our diagonal matrix is I pi minus I pi 0 0. Okay, so now we want to find out Lambert W of, what was that, 0 0 pi minus pi 0. Yeah, we know that this matrix is now a PDP inverse. Yeah, so basically I minus 1 1, yeah, and then I pi 0 0 minus I pi, and then I minus 1 inverse. Now we know that Lambert W can be taken in the main diagonal, which I have already said in the beginning of the video. I minus 1 1, and then Lambert W of I pi 0 0 Lambert W of minus I pi, and then we have I minus 1. Okay, so now the problem is to find out Lambert W of I pi. Yeah, so how do we deal with that? Let's try to use Wolfram alpha for that. Yeah, so Lambert W of I times pi, what do we get? Let's see. Okay, let me write here notation, and let's just see if this works or not. Okay, let me also write that where W is Lambert W. I think now this should work. Lambert W of I pi. Why isn't it working? Lambert W I pi. Oh, it says a huge number. Okay, so let's go ahead and see what happens. Let's just do it. Yeah, I minus 1 I 1. Now if we multiply these two, what do we get? I times Lambert W of I pi, and then 0. Yeah, and over here what do we get? I times Lambert W of I pi again. Is it? Yeah, and over here minus Lambert W of minus I pi. Yeah, and over here, okay, minus Lambert W of minus I pi again. Oh, but wait, I forgot to take the inverse. My bad. Let us go back to over here and take the inverse first. I'm extremely sorry for that. So inverse will be 1 by 2i. No, how 2i? This is minus I. And is that plus I? Is it minus I and plus I? Okay guys, this is getting crazy now. This is just minus I. Okay, this is not minus 1. Sorry for that. So many mistakes, bro. Now I think it's fine. Okay, now this is 2i. How do I know the answer? Yeah. I plus I 2i. Now inverse is 1i. Swap them and minus I times 1. 1i minus I times 1. Okay, now it's fine. Okay, now after this we can just take 1 by 2i at the front because this is a constant, and I minus 1 I 1, and then multiply this. So this is basically lambda w of I pi. Yeah, now minus I lambda w of I pi, and this is lambda w of minus I pi, and then I lambda w of minus I pi. Is that true? Let me check first. Okay, that is true. Now again let's multiply. 1 by 2i. If you now multiply this, what do we get? I lambda w of I pi plus I lambda w of minus I pi. Okay, and next what do we get? This is lambda w of I pi, yeah, minus lambda w of minus I pi. Is that minus I pi? Is that it? Lambda w I pi minus, yeah. Now when we do this, we have minus lambda w of I pi, and then plus lambda w of minus I pi. Yeah, and over here we have I lambda w of I pi and plus I lambda w of minus I pi. Okay, so now we have this result. Now what do we do with this result? What do we do with this? First of all, let me check if these are correct or not, and then I will think of something. Okay, these are true. Yeah. Now let me put in from alpha again if this result makes sense or not. Lambda w of I pi minus lambda w of minus I pi. Let me see. Lambda w of I pi minus lambda w of minus I pi. Let me see if that result is something good. Oh, is it not? Okay, this result doesn't really make sense. But why is it not making sense? Okay guys, so what I basically thought was, I don't really know like why did this not work. Actually, the reason why log and e work is because they do have an infinite series, yes, and we do have similar infinite series. Okay, wait. why isn't this working? Let me, the infinite series for Lambert W of x. Mm, Basically, the reason why those two things worked. Okay, so I think because in the power of the infinite series of Lambert W f x, since there is okay, so no, it should also work. Okay, so since in the in the series for E and ln of x, in the base there was uh, x, yeah, the x wasn't really varying. So we just had x to the power n factorial, and we didn't have such terms. Is that the reason? But no. No, I'm not really sure why isn't this working in Lambert W of x, just like in ln and e to the power x. This should have worked. And my guess was actually my guess was because this matrix is just negation of I pi. Yeah, because I is just 0 minus 1 1 0. This matrix is just negation of I pi. So I was basically taking Lambert W of minus I pi. That would be Lambert W of I pi, and again minus is e to the power I pi. So this is just I pi. Yeah. So I was thinking that the answer that I would get is I pi. That means 0 minus pi 0. I was hoping to get this answer, but lol, I got something very bad. And if I made any mistake, please let me know, and please solve this and let us know in the comment section, like, if this can be true or not. Yeah, that's for you.